All right, I'm going to go ahead and get started. Thank you, everyone, for coming, and those of you who are still eating lunch, feel free to stick around if you want to. Happy to have you. I'm going to talk about step up your SaaS game, serverless orchestration and automation for SaaS. So we'll get into the little things. What are we going to talk about today? I'm going to start off talking about a little bit about being able to do Lambda-less AppSync for SaaS. And this really is more about how you can use step functions to do tenant-specific workloads, just kind of using this as an example. We'll talk a little bit about tenant provisioning, actually spend probably most of the time on that. And then just a little bit at the end about multi-account provisioning. If you have multiple AWS accounts, some things you can do to make that work as well. A little bit about me. I am Jason Wadsworth. I'm Chief Architect at Armanino. We are a top 20 accounting firm doing some kind of interesting new stuff, trying to help out our firm to be a little bit more efficient and move the bar a little bit forward. I am a fifth-year AWS Community Builder. It's a great program. If you guys haven't heard about it, I encourage you to look into it. It's a fantastic way to both learn and share knowledge. So if you guys are interested, check that out. They have new signups once a year. So I've got over 20 years building software, over 13 years in AWS, which actually is kind of surprising to me when I think about it. Over half of the time I've been writing software professionally has been using AWS. I'm a startup junkie. My current job is not a startup, but I've worked at 7 different startups over my career. I really try to take some of the mentality of that startup even into the job that I've got today. I'm a SaaS enthusiast. You'll hear me talk a lot about SaaS. Obviously, this topic today is SaaS, but I do a lot of different talks on various SaaS topics, and I'm a lover of serverless. We take kind of a serverless first approach to things, so I will talk largely about serverless things when I'm presenting and talking about things. And I love Legos. So you can see a few of my things in the background there. I have a growing, probably much to my wife's chagrin, a large collection of Legos. All right. Let's talk a little about Lambda-less AppSync for SaaS. So for those of you who don't know, AppSync is a GraphQL service in AWS. It's just kind of offloads some of the overhead of managing of GraphQL. It's actually a really great service, has some great functionality in it. And one of the things that it does is it has this ability to do direct integrations. And so I'll showing the example here of AppSync talking directly to DynamoDB. And what that allows you to do is, as Darko actually mentioned earlier, there's so many things that we do. They're just like create, read, update, delete kind of operations, right? And there's not a whole lot of complexity to it. And so the AppSync direct integration allows you to connect directly. You don't have to have that compute layer in the middle, right? So that means that I don't have to have a Lambda function running. I don't have the cost of the Lambda function. Don't have the overhead of updating code in Lambda function whenever there's security releases. And don't have cold starts of Lambda functions. 3 pretty powerful benefits of this direct integration. Unfortunately, because of the way that works, the permissions for AppSync to do this, AppSync has to have permissions to access that entire table. And so if you're doing a deployment that is pooled in a SaaS application, which is a really common approach, you really want to try to do some data isolation. You want to make sure that you don't allow one tenant to accidentally get at another tenant's data. And so there's some things we do, and this is kind of the typical approach that we take to this. So we'll have AppSync. We have a custom authorizer in front of it. A custom authorizer is just every time the request comes in, it hits this from an authorization perspective, and you can do some caching here. We do some basic information where we validate the user. But we're also going to call into STS, the security token service, to get some temporary credentials. And those temporary credentials are scoped down to only be able to access that particular tenant's data. And then we take those credentials, we pass it back through AppSync. AppSync passes into the Lambda function. The Lambda function itself does not have permission to access our DynamoDB table. We only allow that function really to do log writing, things like X-ray, right? Very limited permissions. So it has to use the credentials that we give it to access that DynamoDB table. And by doing this, we're making sure that we don't have a situation where somehow via some bad code that got deployed, whatever it is, we don't have that Lambda function trying to access a tenant's data that they don't have access to, right? The credentials that they use will only allow them to access the tenant that they're supposed to access. If there's bad code in there, it will not allow them to access the wrong tenant's data. It'll throw an error, it just won't work. So how can we do this by using step functions and not having to have that Lambda in the middle? About a year ago, a little less than a year ago, I think, the Step Functions team introduced what they kind of pushed out as cross-account tasks and step functions. So if you're familiar, step functions allow you to do a lot of executions. It's a state machine, effectively. And the way that it works is the role that the step functions is given has to have permission to do all the tasks. That's the way it was designed, right? So if you wanted to do a whole bunch of different things, that step function had to have permission to do all those things. And they introduced this ability to say, you know what, let's allow them to do things cross-account. And in order to do that, we're effectively going to say, give us the role for this particular task, and we will call STS for you, and we will assume that role and be able to do things with the context of that role. Now, again, they introduced this as cross-account because that was kind of the driving force, the use cases that they were really trying to meet. However, it doesn't have to be cross-account. It just needs to be a role that is outside of the step function itself. So, what I figured out we can do is we can change things around a little bit here. Now, we're still calling a custom authorizer. And the reason, of course, we have to do this to do some validation of the user. But the other thing that I wanted to do here is I wanted to protect against accidentally assuming the wrong role. So we actually generate a role that is unique to the tenant, and it's got a unique name. It's just a generated name, so that you can't just know what it is and put it into a string somewhere. We pass that back through AppSync, and AppSync takes that to the step function. The step function then uses that role and calls STS, uses that role, and now it can go talk to DynamoDB directly. Now, DynamoDB, Step Functions has integrations to all kinds of different things within AWS. It's actually pretty much everything that you can do from an SDK perspective. You can use DynamoDB or Step Functions to access. So we're effectively able to get a lot of the benefits. We don't have any code to update anymore. I've gotten rid of cold starts. I don't get all the cost savings because there are costs of running step functions. As a matter of fact, they're really similar costs to Lambda functions. But I'm able to kind of reduce this and still give myself that data protection that I'm looking for, right? If I'm building a SaaS application, I don't have to worry about the tenant accidentally accessing the wrong data. And that was really the driving force behind this. All right, there are a few things to be aware of. First and foremost, every tenant has to have its own role in this model. Now, that's important for a couple reasons. One, there's a hard limit on the number of roles you can have in an AWS account. I think it's 5,000 right now. And so obviously your application has a lot of roles that are going on in it. And so if you have, if you have a small number of tenants, this is perfectly fine, right? If you, I kind of cap it at like maybe 1,000 to 2,000 max tenants that you want to be able to do this. Beyond that, you start having to think about a multi-account strategy. And of course, I'll talk about a little bit of that as we move on. The other thing that's important to keep in mind here is that anything that you change in these roles, you have to manage, right? So in the initial example, where we were doing the assume role ourselves, what we were doing there is we have a single role that we can manage pretty easily. And then we have some code that dynamically generates a policy. And that, again, can manage that pretty easily. Two places that I have to manage things and update it. But now I have to manage something for every one of my tenants. It adds a lot of complexity. Fortunately, I'm going to talk about that next, so we'll get into that. The other thing that's kind of specific to this example, the DynamoDB mapping in AppSync's direct integrations is really convenient. It takes the DynamoDB-ness of the data and turns it into JSON. That doesn't happen at the SDK integration for Step Functions, so you have to like kind of work with the raw DynamoDB data. It's a little bit kind of clunky to work with if you're familiar with it. But it still gives us the results that we're looking for, just has some limitations. All right, so tenant provisioning. Again, when we're working with SaaS applications, there's a couple models we work with primarily. We have a pooled model and we have a siloed model. In the siloed model, you're deploying your complete application for every one of your tenants. In the pooled model, you're trying to share things as much as possible. And when you're sharing things, you still quite often find yourself wanting things within your pool to be unique to those tenants. And in the example that we just gave, I want to have a role that is unique to every one of my tenants, right? So I'm going to share all the resources, same API endpoints, whether it's API gateway or AppSync, same Lambda functions, same DynamoDB tables, S3 buckets, but I want to have a unique role that I'm going to use in different situations. How can I manage that? This is kind of the way I used to do it. We would have an event bridge event that would fire whenever a new tenant was created. And that would fire a Lambda function, and ultimately we would use the SDKs. And the SDKs would allow us to do whatever we needed to do. If I was creating an IAM role, we would create that IAM role. And that worked. There were some downsides to that. First, we use CDK. And specifically, we use L2 constructs. And if you're familiar with L2 constructs in CDK, they kind of abstract some things away from you. And so the mental model of working with CDK is different than the mental model of working with the SDK. And so there was just a little bit of a mismatch there of how you think about things when you're usually doing things to how we were having to do things within the code to deploy that. So just came a small barrier, but one that wasn't too terribly bad. The other thing was there was not like a place that I could go and see like what are all the things that exist for this particular tenant, because they're just being created in code. Like if there's just one thing, not a big deal, right? I know they have a role and I can go look at the roles, and that wasn't a huge deal. But when it starts spreading out, there wasn't a kind of a general place where we could see them all. The biggest thing though, updates became particularly challenging, right? It was easy to say when a new tenant's created, let's go create this particular resource. But what about when I need to make updates to that resource? I don't have an event that says I need to upload these resources. That's a deployment, right? It's a deploy time process versus an event within the system, an application level process. So updates became challenging. We ended up having to write some kind of like custom code that we would have happen during the deploy process and have rollbacks and all that stuff in there. And it was just a little bit clunky. And then that code would get thrown away as soon as it got deployed. It was useless, and we'd throw it away. So it wasn't great. So I started looking at some different options, and actually there's some stuff that I've come across from various people at AWS that kind of drove some of these ideas, and kind of I just kept expanding on it. So what we're doing now is we have some CDK code, and I'll show you kind of what this looks like. And that CDK code creates a CloudFormation template, and it puts it in an S3 bucket. And then we have an event that triggers whenever that happens. So you can have events triggered when something lands in a bucket. And that actually kicks off a step function that updates, and I'll show you the details of this in a minute, but it lists all my tenants, and then it calls and updates the template for every one of those tenants via CloudFormation. Now, what I'm not showing you here is we still also have to have the create. It's very similar. We use that same S3 bucket template. We have that same event that we were doing before where we had a new tenant was being created, but now we're calling a different step function where we just are going to call and create that specific tenant's template. All right, so what does this look like? Try to keep this to where you can hopefully read as much as possible. This is a stack. This is a CDK stack piece of code, so kind of off the screen is some stuff related to that. The first thing to notice here is there's a parameter, a CFN parameter, and if you talk much to CDK people, they kind of tell you not to use these. I agree with that in general, but this is kind of an exception. So because our output here is actually the template. The output isn't, unlike most things in CDK where your output is the end result is the deployed thing. In this case, the output is actually the template, and we need that parameter to be able to run this for every one of our tenants. I'm showing an example of a role here, and the important thing down here is that role has a condition statement on it for DynamoDB that says we can only access this particular tenant's data. Their leading key or the partition key in DynamoDB must start with the tenant's identifier, otherwise they can't access it. So no matter what they try to do, they will not be able to get at any other data. All right. In order to use that, we need to get that template deployed. And so above this on the screen, what you're not seeing is I'm creating an S3 bucket. And that S3 bucket is really just going to be where we put this template. We create a stage, and a stage is kind of like a collection of things that are going to be deployed. And then we have that tenant template stack, which was the previous screen. The important thing here is the synthesizer. So the default synthesizer in CDK is going to use your context information and your environment variables and all this stuff to generate the templates in the form that they are meant to be executed directly by CDK. But by using this bootstrapless synthesizer, we're saying don't use any of that information. Ignore what's in my context. Just generate the raw template as it is. So we're going to use that. And then we're actually going to synth that. So within our template, we're actually going to have this kind of like multi-level of CDK, right? We have an outer stack. That's this template is the outer thing. Within it, we're going to synthesize another stack. And then we're going to grab that, and because we know we only have one stack, we're grabbing index 0, and we're grabbing the full path of that. And so we take that template path, and we're going to use the bucket deployment CDK construct that allows us to take that and just deploy that entire stack into an S3 bucket. Again, the S3 bucket that's declared right above this off the screen. So this allows us to effectively have CDK generating all of the infrastructure we have for our application, but this tenant-specific management information gets created and synthesizes a CloudFormation template, puts it in an S3 bucket for us. And then that will trigger what was on the previous screen, which ultimately triggers the updates and creates. All right, so we need a couple step functions. Actually gonna show you 3 of them here. This one is pretty straightforward. This is when we have a new tenant that's created. We kick it off and we call create stack. And we're gonna use the template that is put in that S3 bucket. We have a known path, so we can kind of pass that in here. And then we start doing a little bit of looping. We do the scribe stacks, and we're basically just trying to see if that template is completed. And of course, we show success if it's done. If it failed, we will report a failure, and then we can put some monitoring alarming around that. And we're just kind of looping on the other side of it if it's not in a completed state. Not too complicated, pretty straightforward. Allows us to then now anytime a new tenant is created, any resources that we put in that CDK template get deployed automatically for that tenant. All right, so now let's say we have an update to the stack. And so we've made some changes. Let's say we added permissions. We had DynamoDB in there before, now we want to add S3 permissions. And so we made a change, and now we need to get that deployed to all of our tenants. We deploy that, and it triggers that step function, this step function, when that template is updated. The first thing we're gonna do, and I kind of simplified this a little bit, but we're gonna get a list of our tenants. And I simplified it because if you aware DynamoDB needs pagination to be able to get through your whole list. I'm not showing the paging that needs to happen here, but effectively what we're gonna do is we're gonna call a map state, or distributed map is probably the better way to do it nowadays, but we're gonna call a map, and basically for every one of our tenants, we are going to kick off another step function, which is gonna be the update function. So again, this one not too complicated. This one's a little bit more complex in its appearance, but it's really not too bad. The first thing we're going to do is we're going to describe the stacks again. And the reason this is important is because imagine you have a new tenant that was just created, and then right after that tenant starts creation, we push a new update. Now I have that tenant, that stack is being deployed, and so it's in the deployment state. It's going to take a little bit of time. If we try to do an update right then, it would fail, right? So we need to have some process to check to see if it's an update state. And it's also important that we get that update out there, right? We need to make sure that we got the latest one out there for our new tenant. So we're going to keep looping until it's in a state that can be updated. And then once it's done, we're going to call an update stack. Again, using the new template that we just pushed into that S3 bucket. After that, it looks just like it did on the create. We're just going to loop and wait till it's done and make sure that we're in a good state. And if it's not, we're going to report an error and kind of eventually send that to teams that can manage that and make sure that they're managing alarms. By doing all this, now we have a situation where whenever we have a new tenant created, we have CloudFormation that was generated via CDK. So from the developer perspective, they're using CDK through the entire thing. New tenant information is created, infrastructure is created for that particular tenant. And then whenever we need updates, all of my tenants are getting updated automatically. This makes things so much easier. For us, we don't have all the complexity of having to do SDK code and managing updates and rollbacks, because again, like when you're doing updates and rollbacks in the SDK, you have to manage the state that it was in so that you can manually roll it back and all that stuff. It really gets pretty complicated. CloudFormation is kind of taking care of all this for us. All right. What about multi-account? So, if you have multiple AWS accounts, you need to kind of do the same sort of thing. My first thought was, I'm going to take advantage of the cross-account role. Right? I've got the step function that's running and will give me a list of all my tenants, and I can just start calling that run update for every one of my tenants. Seemed like a really good idea. Turns out to be a really bad idea. Here's why. First, it doesn't allow for rolling deployments. So if you've got multiple AWS accounts, they likely are not all being updated at the exact same point in time. And so as you update your AWS accounts, you want to make sure that the deployment of any resources that are unique to your tenants are getting updated with the correct code, the correct deployment, right? So if you've got 10 AWS accounts, you might deploy to one first and kind of see how things are going, kind of make sure that things are good, and then you roll the next one and the next one, and maybe eventually get to everybody. So by taking that approach of using the cross account, it effectively was like as soon as the first one was done, I was going to deploy to everyone, or I was waiting until everyone was deployed to deploy any of them. Neither of those are particularly great. The next thing, I don't know if anybody here has dealt with multi-account, multi-region CloudFormation, but it is a royal pain, like a royal pain. I actually had an entire project that I did around this years ago before they kind of added some pipeline stuff to simplify some of these things, but it still is really difficult. The main thing is that from a permissions perspective, you can do a lot with organization units to be able to allow access from CloudFormation across, or for the S3 bucket across the different accounts to allow your CloudFormation to work. But that doesn't work across a region. And this is really important because everything in CloudFormation effectively needs to live in the region that it's deploying to. So if you have an S3 bucket that's in US East 1 and you need to deploy to US West 2, then your resources, you need to copy that information over to US West 2. And so effectively you end up having to have all these complex things to make sure that they're updated. And of course, when you only have one S3 bucket that needs to be replicated, you can use S3 replication. It's pretty simple, right? But when you start getting past 2, it starts getting really complicated. And so I found that it was just too much. It was way too much to try to manage. So it turns out that really isn't that complicated. What we effectively do is when we're creating every one of our S3, or every one of our AWS accounts, we're deploying CDK to every one of those accounts anyways. So take the exact same thing that we were doing in one account and do it in each of the accounts. The only thing that ends up being different here is that step function that I called, that I was listing off all the different tenants. Instead of saying, give me all the tenants, I'm saying, give me all the tenants that are deployed to this AWS account. And that allows me to deploy each of these accounts completely separately. And now every one of those the step functions are updating and only updating the CloudFormation templates for the tenants that exist in that AWS account. Really reduced the complexity, took something that felt like it was going to be really complicated and made it simple. As a matter of fact, by virtue of doing this, I effectively removed one of the step functions in the way we actually deploy this. And it's just one step function that loops and then does the part that was in the third step function within the loop because we aren't having to do the cross-account thing at all. So because this is distributed map, it effectively ends up looking like it's a separate step function. But in the actual step function definition itself, it's one. So we are down to 2 step functions, one that is for create, one that is for update. The update loops over all the tenants that exist in that AWS account, does the update on each one of those. Ended up being pretty simple. And now when if we add another account, it just gets added. We don't have to worry about any more complexity of cross-account permissions or anything of that nature. Ended up being pretty straightforward. All right, just a little bit of a recap. First things first, step functions can be used to do tenant-specific workloads. Before, you really couldn't do this without having to risk your data isolation or data protection boundaries being leaked. But since they introduced the ability to use a role on a specific task within step functions, you can use them safely to do data protection, and as long as you have a role created for each one of your tenants. Step functions are a great way to manage tenant-specific resources with CDK and CloudFormation. Again, removing yourself from having to use everything with the SDK and instead going to what you're already using in step functions. Even if you're doing CloudFormation, right? You can do the same sort of thing here. You just have to have a few extra things that you have to manage, right? You have to get the bucket, the template deployed. But for the most part, whether you're using CDK or CloudFormation to deploy your infrastructure, by moving to this model, you're able to keep your mental model of how to update your code to the same thing you're doing, whether it's tenant specific or not. And then last thing, multi-tenant or multi-account doesn't really have to be that complicated. It really felt like it was going to be this big deal, like we're going to have to figure out how to do permissions across account and all these things. But at the end of the day, it really wasn't that big of a deal. It was pretty simple. We just took the same thing, made a small tweak to it, and we got what we were looking for. That's all I really have. I really want open to questions if anybody has any. Yep.
Jason, the multi-account strategy where you're starting with a CDK in each account,
Mm-hmm.
are you doing any orchestration across that, or is it just manually calling each CDK?
So what we're doing right now is just using CDK, right? I think as we add complexity and start needing, and if you didn't hear the question, are we using any orchestration across multi-accounts from our multi-account strategy, or just using CDK? We are currently just using CDK, and so what we have in our CDK templates is we actually, in the app part, we actually call out the specific accounts that we're deploying to, and we looked at some different models. I think there's a point where we get to the edge of that makes sense, right? Because when we have a dozen accounts, that's okay. When you start getting to 50s, hundreds, that becomes a little bit more of a scalability issue. We are not there yet, so haven't really hit that boundary yet. Anybody else? Yeah.
If you wanted to deploy update across all your tenants, what level of parallelism do you use?
That's a good question. So we are pretty early in our application. We probably have a couple dozen tenants right now. Literally, like, we just launched live a couple months ago, and so we're growing it. So we're pretty high level. High for us, a 10 is fine, right? But I think that's where you have to worry about your limits on APIs, right? So the big thing there is just to be aware of what those limits are and make sure you're not hitting them, right? Because you're going to run into limits on CloudFormation, how many times you can call their APIs. I actually ran into that by accident. I forgot to put a wait in my describe. And so I was like trying to describe over and over and over again, and it was like, yeah, stop hitting my API so quickly. So you do have to be aware of that, right? And then of course, as you're doing that, all the resources that are inside of it need to be able to be updated quickly as well. That's a problem, frankly, though. It's not unique to this. Because other than the CloudFormation piece of it, because you're going to hit those rate limits no matter what. As a matter of fact, sometimes, and I don't know if this is always true, but sometimes CloudFormation kind of hides those from you, right? So like you might not hit the same rate limit that you would if you were calling the SDK directly. So by virtue of using CloudFormation, you just have the CloudFormation limit, and then the rest of it, they kind of manage for you, right? And I think, as a matter of fact, I've seen bugs where that wasn't happening and it was reported as a bug and fixed. So effectively, the CloudFormation deployment is like, oh, I hit a rate limit, try it again. So it's actually safer in that respect. What else? Anybody?
We're using,
yeah.
We use this design pattern for, other than the tenant-specific thing, are you using this design pattern for any kind of other operational or management type functions?
Are we using this for anything outside of the tenant specific? Not right now. Again, we're relatively young. I mentioned I've worked at startups. We are effectively like a startup where we are right now within our organization, so we're pretty small. But that said, I think the patterns that we're using here are things that we probably will start using in other places. And to your point, right, some things that are more operational can kind of take on along these same sort of things. Whether it's using different security features and security lake stuff, I think some of that stuff you can kind of automate, but there's certainly pieces of that where operationally you want to do updates across your entire environment and you can use the same sort of model. Anything else? All right, thank you everybody, appreciate it.